back to it. It's Maths Master Class with Leo. Today we are doing functions, grade 12. So our focus area is on functions, right? So introduction to functions today. So we'll start with linear function, which is the first one and which is the easiest, wherein the general equation or the formula for a linear function is y is equals to mx plus c, or other textbooks they can say y is equals to ax plus q, right? So those two formulas, they represent the same thing. Y is equals to mx plus c, y is equals to ax plus q is the same thing, where m represents your gradient, and the gradient formula m is equals to y2 minus y1 divided by x2 minus x1. This is the gradient formula, right? So some will say a is equals to y2 minus y1 divided by x2 minus x1. These two things, they represent the gradient formula, right? And with the gradient of a straight line, it is you can get two or three graphs of a linear function, right? So now the first graph, where a is greater than 0, meaning the value of a is positive in this case, right? Positive. A is greater than 0, meaning a is positive. Your graph will look like this. Your graph will be something like that, right? This is how your graph will look like. Now, in this case, it tells you your graph will start from negative infinity up to positive infinity for both x and y. This is going to be your negative infinity. This is going to be your positive infinity, right? So in this case, when I'm saying it starts from negative infinity up to positive infinity, we're not sure where it starts exactly. Hence, we have these arrows, right? Hence, we have this arrow and this arrow. So now, with the graph of a positive function, you can see that when x values increase, also the y values increase, right? You can see that it starts from negative x up to positive x. It also starts from negative y up to positive y. So remember, whenever you are checking your graph, you'll always start from negative x. You'll always start from negative x in order going to positive x. Hence, say it starts from negative x values, where in this case, from negative x values, we're increasing up to positive x values. Also, in the y value, we're starting from negative y values up to positive values. This graph is called an increasing function. This graph is called an increasing function. Not functions, function, right? So when the x values are increasing, also the y values are increasing, that function is called an increasing function. Let's get to second part. Now the second part is when now your graph is like this. Your graph is like this. This is x plus y minus y plus x minus, and then say your graph is like that. In this case, we are saying this graph, the gradient of this graph is less than 0. Gradient is less than 0, or a is less than 0. Both a and m, they represent the gradient, don't forget that. So in this case, meaning the gradient is negative here, negative gradient. Right? This is a negative gradient. You can see that when the x values increase from negative x values up to positive x values, the y values are decreasing. So when x values increase, y values decrease, right? Therefore, this graph, it's called a decreasing function. This graph is called a decreasing function, right? So we've covered how does the value of m affect your graph. So the value of m, when it's positive, your graph will be increasing or an increasing function. When the value of m is negative or less than 0, your graph will be decreasing. For an increasing function, gradient is positive, greater than 0. Decreasing function, gradient is negative, less than 0. Now, let's talk about this guy. That part, the constant part. That represents the y-intercept of the graph. Again, we have y is equals to mx plus c, where this c, it is the y-intercept of the graph. That is the y-intercept of the graph, right? So in this case, even if you write it like this, y is equals to mx, or y is equals to ax plus q, ax plus q, that simply tells you the value of q, it is the y-intercept, right? So the value of q in this case, it is the y-intercept. Okay, let's move. Now we've covered gradient, we've covered y-intercept, we've covered how the nature of your gradient affects your graph. So now, remember, whenever you have parallel lines, say for example, they're saying this is your first line, this is your second line, this is A, B, C, D, and they're saying AB is parallel to CD. Therefore, the gradient of AB will be equal to the gradient of CD, right? When the two lines are parallel, their gradient will be equal, right? Now let's come to perpendicular. When you have perpendicular lines, say for example, like given something like this, and then they're saying this is still your A, B, C, D. So in this case, the gradient of the two must give you negative. The product of the two gradients must give you -1. So if I say the gradient of A, B multiply gradient of CD should give me -1. Right? And lastly, we know that the gradient is equivalent to tan theta. Right? We know that the gradient of a straight line is equivalent to tan theta. Now let's come to domain and range. So if I have, okay, what's happening? Domain and range. Okay, say I have a graph like that. Same thing this side. Okay, this is my y minus, x, and x minus. Still x, y minus, x minus. Now I have a graph like that, right? I have two graphs like that. From these two graphs, you can see that these are decreasing functions. So the domain of this graph is x, is the element of real numbers, because it exists in the negative x values and in the positive x values, right? Some of you can write it like this: x element from negative infinity up to positive infinity, right? These two things, they mean the same thing, and both of them, they are correct, right? And then it tells you your graph starts from negative infinity up to positive infinity. Even this side, I'm allowed to say y is the element of real numbers, or y e from negative infinity up to positive infinity, right? In this case, you can see it starts from y positive going down to y negative, right? And then let's talk about a graph that looks like this. X, y, y minus, x minus. Okay. Then here, same thing. X, y, x minus, y minus. Right? So in this graph, as well as looking at this graph and that graph, the domain will be the same because it exists both in the negative and positive x. So I can say x is the element of real numbers, right? And x from negative infinity up to positive infinity. Even this side, I can do the same. Y is the element of real numbers. Y e from negative infinity up to positive infinity, right? So those two things are the same. They mean the same thing, right? So in this case, the graph of a straight line, that's how you're gonna get the domain and range of the graph. The domain and range of the graph, that's how you're gonna represent it. Okay, let's move to a parabola. With a parabola or quadratic. A parabola or a quadratic function, first formula, you have y is equals to ax squared plus bx plus c, right? Second formula, you have y is equals to a into x minus x1, x minus x2, right? This formula, you use it to calculate the value of a when you are given intercepts, when you are given x-intercepts, right? You can use this formula to calculate the value of a. Use when given x-intercepts. Right? And extra pair of coordinates. Right? You can use this formula. Meaning, if I have a graph like this, then my graph will be looking like that. If I'm given this point, let's say this is A and this is B. I'm given the coordinates of A and the coordinates of B. Maybe one last pair of coordinates here, and these are the coordinates of C. They gave me all these three coordinates. I can use this formula to calculate the value of A and eventually calculate the equation, right? And then the third one is this one. Y is equals to A into x minus p squared plus q, right? Where p and q represent the turning point. So you use this formula to calculate the value of a when you are given something like this. Say your graph is something like this, and then they gave you this point. Say this is a, and this, say, is p is to q. You are given the coordinates, and you're also given the coordinates of maybe this point. Say this is b, right? And they gave you those coordinates. So when you have these two coordinates, you can calculate the equation of a quadratic or a parabola, right? You can use this to calculate the equation of a quadratic or a parabola by starting with the value of a. You can start calculating the value of a because you'll be having p and q and these coordinates which you can substitute at y and x. Okay, then we move y-intercept of this graph. Y-intercept in this case, y-intercept For y-intercept, we're looking at the point where x is equal to 0. So in this case, it is at that point. And that point is represented by this. Y-intercept is equal to c. Right? Y-intercept is equal to c for this equation. Then, you know how to calculate the x-intercept? For you to calculate the x-intercept, y should be 0, right? For x-intercept, y is equal to 0, and then you're going to get your x-intercept for a parabola. Then the turning point, the equation of a turning point, how to calculate the x value of the turning point. X is equal to minus b over 2a. This is how to calculate the x value of the turning point. This is how to calculate the value of p. Right? And then after getting the value of p, you will substitute that p where? On your original equation. Substitute that p on your original equation to get the value of q. Right? Okay. Let's see. Okay, let's see. A minor problem. Let's see what's it. Okay, we are back. Let's see. Now, I was saying, for you to calculate the q, which is the y-intercept of the turning point, you'll substitute the value of p on your original equation. And how to calculate p? You calculate it using this formula. Right? After getting the value of x, which is equivalent to p, you can use it to calculate the value of q, which is the y coordinate of the turning point. Right? As I was saying, x, once you get x, in this case, x will be equal to p. Right? After getting that, you can use it to calculate the value of q. Let's go to the next page. Now, as I was saying, when you are given the turning point, when given the turning point, you can use y is equal to a into x minus p squared plus q. This is the formula you can use to calculate your value of a, and after calculating the value of a, you'll eventually be able to calculate the whole equation. Right? And then when you are given the x-intercepts, so you will use y is equal to a into x minus x1, x minus x2. And then now let's come to our domain and range. Say I have a graph like this, another one like that. Okay, these are my two graphs. They want to know what is the domain and range of this graph. Looking at this, I have my x minus, my y minus, and my y plus. Right? And then I have my y minus, x, y, x minus. Right? And then from there, they want to know what is the domain of this graph. The domain of this graph, you can see that it exists both in the negative x and positive x. Right? So you will say, well, x is the element of real numbers. Or you can say x, e, from negative infinity up to positive infinity. Right? Even this side, the range. Now, the range depends on the turning point of the graph. Range depends on the y value of the turning point. Basically, the range of the graph depends on Q. Ne? Depends on Q. Right? So, as I'm saying, the range depends on the y value of the turning point. That y value of the turning point, it is the value of Q. Right? So, if you look at this graph, it is a smiley face. Right? This graph is a smiley face. Therefore, my range must be what? X, not X, but Y. Y is the element, right? From Q up to positive infinity, right? From Q up to positive infinity. Or someone can write it like this and say Y is greater than Q, right? From this point, this is the y, somewhere here, it is the y value of the turning point. My graph will always be moving from that point going up, going that, like that, right? Hence we say it will be greater than Q, or it will start from Q, not per se greater than or equal to, because it starts from Q, it goes up, right? From Q, it goes up. This, it is where our range depends on. It depends on Q. Hence I say, Y is the element from Q up to positive infinity, right? That is how you'll represent this in your range. Someone might write it like this: Y greater than equal to Q, and then say Y is the element of real numbers, right? So these 2 points, this is correct, but it's partially correct. This is very much correct. You'll get 2 marks for that. It shows understanding of domain and range. It shows that you understand better what is domain and what is a range. Now, let's move to the second graph, which is a set face. Your graph is now something like, okay, let me just get some space. I'm still looking for the domain and range, right? And then my graph is now facing down, which is something like this. And similarly, this side, I have something like this. This is X, Y, Y. This is Y minus, X minus, Y minus, X minus, X, and Y. Having these 2 graphs, they want to know what is the domain. Domain is easy. It exists both in the negative part of X and positive part of X. This is X, the element of real numbers, or X, element from negative infinity up to positive infinity, right? Then when we come to range, what did we say? We said range depends on the Y value of the turning point. It depends on Q. So in this case, if this is my Q, or this is my Y value of the turning point, it will always be going that side, my graph. So it exists below my Q, from my Q and below. So I can say Y, right, element from negative, okay, let's do this, from negative infinity up to Q, right? That is how I'm going to write it. Then for this, you're going to get 2 marks. This is 2 marks, or 3 sometimes. If it's 3 marks, you get full 3 marks. And then you can also represent it like this: Y is less than equal to Q. Q, right? And then Y is the element of real numbers. So in this case, the reason I'm using Q is because I don't know the exact value of the turning point, so of the Y value of the turning point. Whenever you have the exact value of the y value of the turning point, you will substitute it where there's q, here and here. You substitute it, right? That is how you're going to represent your domain and range of the graph, right? And again, the value of a influences the shape of the graph. A, if a is greater than 0, meaning a is positive, your graph will be a smiley face, like this, right? So a very much influences the shape of the graph. Now, when a is less than 0 or negative, your graph will be a sad face, something like this. So I'm telling you this simply because when you start drawing the graphs, be aware of that. When you're calculating the value of a, if they gave you a graph already, when you're calculating the value of a, you'll be able to conclude that my value of a is correct or not, looking at the shape of the graph. If your graph is a smiley face and you get a negative, you'll very much be aware that your solution, there's a mistake with the solution. So you'll go back and fix the solution until you get the positive value for the smiley face, right? Then that is it for parabolas. Let's come to hyperbolas. Hyperbolas, they are also easy. Let's move to the next page. Formula for a hyperbola: y is equals to a over x minus p plus q, right? And then from there, now when the value of a is positive, your graph will be like this. Let's draw it here. Your graph will be like this. It will be in the first quadrant and the third quadrant. That is where your graph will be lying, right? So when the value of a is greater than 0, meaning the value of a is positive, this is how your graph will look like. This is the graph where the value of a is greater than 0, meaning the value of a is positive, right? That is how your graph will look like. And then when the value of a is less than 0, meaning the value of a is now negative, your graph will look something like this, like that. This is my y minus, y plus, x plus, and x minus, right? This is how your graph will look like. It will be in the third and fourth quadrant when the value of a is negative, right? Now with this graph, you have asymptotes. Don't forget that. You have asymptotes. So in this case, our graph, it is the original graph. The original graph, it is where y is equals to a over x. Just like that. Because the value of p is 0 and the value of q is 0. That, it means your graph will never touch this point. Your x-axis and your y-axis. Right? There, your asymptote is at 0 and 0. Those are your asymptotes. So the x value of the asymptote is 0 and the y value of the asymptote is 0 in this case. Then we come to equations of asymptotes. They'll ask you to determine the equation of the asymptote. This is x is equals to p, right? Then when we have the value of p, you substitute it. Then it will be in terms of the equation, not p is equals to the value that you got. If you say p and they say the equation of the asymptote, your answer is going to be wrong, right? So this is the equation of the asymptote. If you have value of p, let's say for example, in this case, the value of p is 0, then my equation of asymptote will be x is equals to 0. And then y is equals to q. So if they say the equation of the asymptote for y, this is it. Y is equals to q. And if I know what is this, I'm going to say y is equals to 0. This one and this one are my equations of asymptotes, right? Not most of you, they say equation of asymptote, you write this. You say p is equals to 0. Wrong. Q is equals to 0. Wrong. You are making it easy for a person who's marking to give you a wrong. So let's avoid that. Let's avoid doing those type of mistakes, right? So now you'll have an increasing function of a hyperbola, an increasing function of a hyperbola. Now, with an increasing function of a hyperbola, increasing function of a hyperbola. Now, you will have something like this. These are called axis of symmetry, right? An increasing axis of symmetry looks like this. It looks exactly like this. It is the straight line that cuts your graph into two equal halves. That is an increasing axis of symmetry for your graph. And its formula is y is equals to x plus c1, right? Meaning, now the value of c1, you will calculate it by using your equations of asymptote. The easier way of writing it is to say y is equals to x minus p plus q. This way is easier because you'll always remember, what am I calculating? What am I substituting here? I'm not substituting any points except for the equations of asymptote. Or not the equations of asymptote, the values of asymptote. The coordinates of asymptote are the ones that I'm going to substitute where there's P and Q, right? So don't forget, you always use coordinates of asymptote to calculate the axis of symmetry. And this is the positive one, this is the increasing one, right? They'll ask you calculate the positive x or the equation of asymptote. No, the equation of axis where the gradient is positive. This is the one. Now they'll also ask you to calculate the axis of symmetry where the gradient is negative. It looks like this. Crosses here, goes up, like that. This is the axis of symmetry which the gradient is negative with a decreasing. This is the decreasing function. Decreasing function. Right? This, we call it y is equals to x. Y is equals to minus x plus c1 minus x plus c1. Or you can write it like y is equals to into, this is negative x, negative p plus q. Right? That is how you can represent that one. Where p and q are the coordinates of asymptote. Where here you substitute, if you want to use the first formula, don't forget, you substitute the coordinates of asymptote. Substitute the coordinates of asymptote there to calculate the value of c. Then after that, represent it in terms of an equation, y is equals to mx plus c. Then let's move to the next part. The domain and range of the graph. If I have, I'm struggling, I don't know why. If I have something like this, my domain here, my range here, my domain and my range. So in this case, I'm going to have what? I'm going to have two graphs. First one looks like that, like that. Yeah, that's bad. Let me try to do something better, like that and like that. That's and like that. Hey, that's very much better. Y minus, y plus, x, x minus. Okay, you have a graph like that where the value of a is positive. That's bad. Let me try another one. Okay, this is y minus, y plus, x, and x minus. Okay, you have graphs like that, and then from these two graphs, the value of a is greater than 0. You can see the value of a is greater than 0, meaning the value of a is positive, right? So in this type of a graph, the domain of this, it will start from, you can say x. Remember the equation is y is equals to a over x minus p plus q. Remember what? The domain or the asymptote, it is the line that my graph will never touch. The part that my graph never touches, we call it a domain, and not a domain, an asymptote. So in this case, my graph can never be equals to 0. I'm going to say this, x minus p cannot be 0. Take this to the other side, x is equals to p. So x cannot be that. X cannot be p. If x is equals to p, that gives me math error. This is what, when I punch the calculator, I get math error on. If I punch the calculator on the value of p, I'm going to get a math error, meaning that is the part that my graph will never touch, right? So in this case, I'm going to have my domain as x cannot be p, right? And x is the element of real numbers. It can touch any other point except for p, right? It can touch any other point except for p, right? And you can also write it like this, from negative infinity up to p, then union from p up to positive infinity. That is how you can write it, right? That is how you can represent your domain. Sometimes you can represent it like this, x is less than p and x is greater than p. These are three ways in which you can represent a domain, and then let's come to a range. Similarly, range, when y is equals to q, this gives me math error. So it means y cannot be q, because that is my asymptote. That is the line where the line where my graph will never touch, or the part where my graph will never touch. Y is equals to q, right? So in this case, I can say y cannot be q. Y is the element of real numbers, right? And then from there, I can say from negative infinity, q union q positive infinity, or y is less than q, or y is greater than q. As easy as that. I got my domain and range. Even for the next part, you want to do the same thing. Let me clear some space here, and you see. Even for the graph where the value of a is less than 0, it's still the same thing. It's still the same thing. See, domain, range. So in this case, you have your graph like that. It's in the second quadrant and third quadrant. This is x minus, x plus, y, and y minus, right? Same thing, this side, y minus, y, x, and x minus. A is less than 0, meaning a is negative. A is less than 0, meaning a is negative, right? So my domain, I'm going to say x cannot be p. Then x is the element of real numbers, right? From negative infinity up to p, union p up to positive infinity, right? Then x is less than p, or x is greater than p. Then here, y cannot be q, then from negative infinity up to q, union, then q up to infinity. Y is less than q, or y is greater than q. That is how you get your domain and range for that. Domain and range for your graph of hyperbola. Lastly, let's talk about exponential function. Exponential function, which is the last part. Now, with an exponential function, the equation is y is equals to a b x minus p plus q, right? And then if you have a graph that looks like this, know that the value of b is greater than 1, right? And the value of a is greater than 0, positive, right? And then if you get a graph that looks like this, know the value of a is greater than 0, meaning the value of a is positive. Value of a is positive, right? The value of a is positive, and b is in between 0 and 1, right? And then let's come to the negative value of a. When the value of a is negative, your graph will look something like this. Graph looks like this. This is when the value of a is less than 0, meaning the value of a is negative, right? The value of a is less than 0, value of a is negative, and this is when the value of b is greater than 1. And then lastly, you have your graph that looks like this. See, like this. This is when the value of a is less than 0, meaning it's negative, and the value of b is in between 0 and 1. That is how your graph will look like, right? Now you know, if this is your equation, the value of q, it is your intercept. Okay. No. Okay. Y is equals to q, right? That is actually your asymptote, not your intercept. Sorry about that. And then let's come to your domain and range, which is the last part of this. Domain and range, the domain of this graph, when a is greater than 0. So remember, the domain of this depends on the value of q, right? It depends on the asymptote. So in this case, if I were to determine the domain, let me go to the next page. Domain and range. Domain, range. Right? I have a graph that looks like this, and I have a graph that looks like this. Both of these graphs is when the value of a is greater than 0. Both of these graphs is when the value of a is greater than 0. See? Right? So for a domain, you can clearly see that it exists both in the negative and positive sides. X is the element of real numbers. X element from negative infinity up to positive infinity. Right? Now let's come to range. Range depends on the value of q. Right? So for these graphs, the range will always be greater than, for these two graphs, range is greater than, y is greater than q. Right? This is when the value of a is greater than 0, the value of a is greater than 0, meaning the value of a is positive, the value of a is positive. right? So y will be greater than 0. That is, or you can write it like this: y element from q up to positive infinity. These are two ways in which you can represent this range. Let's come to the next one, which is the final one now: the domain and range. So the domain and range of these graphs. Let's say you have a graph that looks like this, and you have a graph that looks like this. You have a graph that looks like this. You have a graph that looks like this. Okay, here, simple: x is the element of real numbers. X, the element from negative infinity up to positive infinity. Right? Because it exists both in the negative x and positive x. Negative x, positive x. Right? So now we come to our range. When a is greater than 0, when a is less than 0, what is the range of this? When a is less than 0, what is the range of this? Now, the range of these two graphs are the same. The range of these two graphs are the same. They depend on the on what you call the asymptote of this graph. So this will be y is less than q, or y from negative infinity up to q. That is how you will represent this, right? So that is it from me and functions. Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Tango means thank you. Tango!